thanks to the vision of my predecessor, Federico and Gino Nicolais, beside me, an important interaction from Fraunhofer. This is, I don't need to present you the importance, the value, the size, the significance, and also recognize excellence of Fraunhofer. So for us, it's a really privilege to interact with Fraunhofer. Today, even the Fraunhofer presence with us, Professor Raymond Mühlbach, correctly. So it's a privilege today, the presence with us in Naples. That means that today we have the possibility to do something very, very important. So we launched this project. This is a very interesting project because, at least for me, looking at the honor to launch the activity today, and they are very interesting because I can see in this project a lot of things, a lot of opportunities, but a couple of two keywords which I like very much. One is sustainability, the other one is bioinspired. Let me just make a couple of thoughts about these two words. Sustainability, they make sustainability can't do anything that is not sustainable. But what's really interesting in this project is the outcome of this project, and the involvement of the Fraunhofer Institute is a guarantee that this project will produce real effect, real knowledge, real science that we hopefully will be able to transfer to the real world. When we realize solutions for increased sustainability. Sustainability in different sectors, in different fields, is a project promises to be effective not only in mechanics, not only in industry, but also in I would say health or in agri-food. So we have the possibility to produce today, to start today, I would say, a new way of addressing a series of issues, a series of constraints that make our production of goods and services sometimes unsustainable. So this project, I believe, is possible. The other thing is bioinspired. Bioinspired is a very special word. A special word for me. I'm a biologist by degree. Bioinspired means take inspiration from nature in order to use some of the solutions that nature has devised, has found to make this function sustainable. In this project in particular, bioinspiration means to introduce new kind of robots, new kind of technologies that use soft materials. They can actually learn how to produce the service. This is a great novelty. We all know that Fraunhofer has a special project for that. We really hope that this project could learn and build on the experience of Fraunhofer, the experience of our research, of our professors, to make something new, something that really promises to be effective. So that I see that the progress of this project is so many. And I can see that in a few years we'll probably meet again to look at the outcome of this interaction. The third things for which I'm very proud for this day, and I'm very thankful to the people present here and the people that made this project possible, is that this is a bilateral project. I would say this is really a bilateral project because two institutions, Fraunhofer Institute and Federico II, they simply decide to go together, they make a co-financing of the project, and they start the project. So it's an equal contribution. It's a contribution made by two institutions that choose the work to work one with each other, and so that is something that we expect to be a seed that could grow, that could produce
more effect, more project, more contribution, of course, allowed us to join project together to get funding outside this agreement to learn a lot from each other. So for this, I'm also very thankful to the people that make this possible, to Professor Antonio Lanzotti, Dr. Stanislao Grazioso, and of course, Professor Stefan Innenfeld, if I'm not wrong in the pronunciation, that came all the way to Naples again to help us, to drive us on this initiation day. Finally, I think that this is a project which also have the possibility to help our students, to go to address the right direction, also in terms of placement, because we really expect that, and we were talking yesterday with the president, we really expect that this kind of, project, the direction, the scientific direction of this project will really push on area which we see, and we're sure that will be the case, area where our best students, our young researchers have the chance to grow and also to make their contribution. And of course, this may be one of the major contributions our university could give to the project, but the main contribution being the creativity, the intelligence, also the technical, I would say, preparation ability of our students, our researchers. So thank everyone for being here. My salutation goes also to Valeria Fascione from the Campania region, who's always with us in all these adventures, always with us. This is for us is very important, very significant, because dear President, when you do science, do education, if you don't have the sustain and I would say the help of the political entities, is very difficult to do almost anything, at least in Italy. I don't know in Germany, but I suppose it's the same. So thank you very much. Thank you everyone for being here. And I'm really proud to say that we are starting to work today on this project, and we will see many different beautiful things coming out. Thank you. Okay. Very good. So the floor is yours, Raymond. Thank you.
Thank you, Matteo. Dear Professor Lorito, dear Madam Minister Valeria Fascione, dear Gino Nicolais. Gino is the bridge in science and research and innovation between Italy and Germany, and especially between Campania and University of Naples and Fraunhofer. And it's my pleasure to welcome also my old friend, Francesco Caputo. Francesco was the founder of the cooperation, I think nearly 20 years before we started here. And now we have such nice projects, like the rector mentioned, between Antonio and Stefan Ehrenfeld here. Thank you also, Francesco, for the long-term cooperation and friendship. This was a basic for the success today. Thank you. And I will also welcome Antonio and Stefan Ehrenfeld, the both professors, which are the leading persons with your co-workers this common project. We officially launched today this Bioic project, and first of all, I would also thank, like the rector, all people and all persons which was involved in the preparation and also in the status that we have at the present time. And before I will give also some comments to biological transformation or biologically inspired technical systems, if you allow, I will also give some main comments to Fraunhofer in general. I think I have here, should I start the slide itself? Yes, I have a small presentation The presentation was prepared by Claudia Kasper, the Director of the Presidential Staff and Communication of the Fraunhofer in general. And I have some words about Fraunhofer at a glance, then some comments to the biological transformation and the chances by biological transformation, and a short outlook. Yeah, maybe we can in the body of presentations. So it's fine. Yes, it's fine. And now we start with some remarks to Fraunhofer. Fraunhofer, so most of you know, is headquartered in Munich, in Bavaria, in Germany. And from the size and from the power of the researchers and the numbers, we are, I think, the largest organization for applied research and for innovation in Europe. And as you can see, we are today 29,000 employees in research and innovation. And we have now in Germany 75 institutes at 100 locations in Germany. And we have abroad 35 activities. And we have cooperation with 80 countries worldwide. The budget in the last year, of course, we have had Corona and the Corona crisis also in Germany. And we could continue our research volume in the level of 2.9 billion euros. So it was a success by all the institutes which contribute to this. And let me say, it was a very excellent experience. In the institutes which have cooperation in innovation with the automotive industry, with they got a little bit problems and the budget went down, but the institutes in IT and in biomedicine, in IT, in biological technologies increased in the last year. And here you can see our international activity. Outside from Germany, we have 8 independent Fraunhofer affiliates in USA, in Sweden, Austria, Portugal, Italy, Chile, and United Kingdom and Singapore. In Italy, we have a special construction in Southern Tirol. This was a fine state in Tirol. But we have also in Italy the joint venture with the Lanzotti. And additionally, we built up 12 Fraunhofer centers also in the different countries. We subdivide between a legal entity and between a Fraunhofer innovation platform. And this we have in 12 countries, and I mentioned how I mentioned, you can see cooperation in 80 countries worldwide. The cooperation worldwide of Fraunhofer is every year nearly 300 million euros. And Fraunhofer activities in Italy is, I think, is of a special interest for you. Our Fraunhofer activities are in north, in south, in the middle, and also in different research fields. As you can see here, for example, we have, I have to look here for my better recognition. We have, for example, automation and mechatronics engineering, process engineering, construction and business models. Then we have in the field of waste and valorization and future energy supply at the University of Bologna. We prepare with Bologna also in high performance computing and in quantum computing. An activity yesterday in the evening, the rector, Matteo, we spoke also about, we have now the first European quantum computer from IBM in Germany in the near of Stuttgart. And I offered also Matteo that researchers from the University of Naples can also use this computer. Of course, on one hand, for the latency, if you want to involve such a computer in real models here, you need an additional light wire, but we can also invite you that you can come with your models and you can be our guests in Stuttgart and you can use and can learn, because I think in the next years more and more, especially the universities, Matteo, gets a chance to use quantum computing. But it's not so easy to use quantum computing. You need special software constructions to access to the computer and so on. And for this, our doors are open for our partners in Naples also. And you can see we are very good connected with Italy. And let me also give a compliment to the Italian partners. We look also, especially for European projects in the European Union, for partners in the level of excellence. And this was in the last years a lot of partners in Great Britain, in Switzerland, but also in Italy. And a lot of institutes in my organization changed now the focus from the partners in Great Britain additionally to Italian partners. And I think this is also a good sign and a good precondition to extend the cooperation between us. And the minister and myself, we have had yesterday also discussions about the needs for Italy to push spin-offs from science in industry. Also in these fields where we won't cooperate in the future. There are problems by law in Germany and in Italy to give very, very good conditions for the spin-offs from the outside, from the university or from Fraunhofer. We have to consider law for public money, and when we give results which was generated by public money, and to give this in the spin-offs is not so easy, but we want to go in this way also together in our countries and also in the European Union. And here you can see the next slide. In the organization is similar like in the university. The rector, I think, can confirm this. If you have a large organization, you have to subdivide the research fields, and we focus. This is a dynamic process. We focus our we focus on strategic research fields in Fraunhofer, and you can see, as you can see, say here in this chart, bioeconomy, digital healthcare, artificial intelligence, next generation computing, quantum technologies. We should not forget, a lot of people speak about, especially in the science, about quantum computing, but we have a lot of chances to use quantum sensors. And we spoke yesterday, Matteo, about the using of sensors in food production, how necessary it is for food security. And also in these fields, quantum technologies play a very, very strong role in the future. And we have in Germany, in quantum technologies, also in quantum communication, a pilot project where we combine, or where we create a combination between two federal departments by quantum communication. If you use quantum communication by photonics, you cannot hack. We cannot hack the Verbindung. So you cannot hack or hacking the connection. You can only interrupt. You can interrupt, but you cannot read out. And this is very important. I think not also for our security in Europe, also in the military and in the sense, it's also very important for the security, or to save our IP in our research organizations. And research efficiency in climate technologies are also a strong research field. And our topic today, biological transformation, biologically inspired technical systems, are in our case localized in the field resource efficiency and climate technology, under the headline research efficiency, and not so strong in bioeconomy. And hydrogen technologies, of course, are also a strong topic. And on the end, let me say, we have prepared, supported by Gino Nicolais and in his responsibility in the federal ministry in Rome, a 2+2 program for the cooperation. Mr. Fascione and we spoke yesterday also about this. The 2+2 means you have an institute, a research institute in Italy, and a company in Italy, and you have a research institute in Germany, and a company in Germany, and also 4 partners cooperate to one research focus for innovation. Every country pay for the efforts for his partners or for his actors, and on the end, the IP, the ownership of the IP is for all, and all together can go for acquisition and to the market in other things. This is, in my eyes, a very excellent format. And here, some words to biological transformation. Professor Ehrenfeld can give you much more deeper insight in details like myself. But this was a topic which I self, as president, have pushed since, or I pushed this since 9 years. And we have also in our international academy, CIRP, Antonio knows this, a large group which work in research and innovation about technological transformation. And by technological transformation, that means using biological optimized systems from the nature for the design in technical systems. And why do we this today? We have now, by the digitization, the chances for a better understanding of the biological systems. We have now solutions for much more complexer systems, and now we can use optimized processes from the evolutionary point to our technical design. And the last chart shows us here in which areas, of course in materials, of course in structures, of course in processes, and we use in these application fields, materials, processes, structures, we use in the interaction between the nature and the technique, the fact of inspiration, the fact of integration, and the fact of interaction. And on the end, we have here an example. The last highlight, which was created by researchers from the biology and from the engineering sector, was to use the so-called facilitated variation by digitization for technical design in systems. And as you can see, what means the facilitated variation? Facilitated variation means it's a modern evolutionary biology theory which combines findings from micro, cell, and developmental biology. Also it combines more the cell level and also the structural level in the evolutionary case for the biology. And the last chart, here is the application. Maybe Stefan is from your institute. This application here. Next one is the turbines. I'm from IPT. Yes. Yeah. Not every times I can rapidly identify comes a solution from his institute, his or this institute. In this case, it's a result from our colleagues in Aachen, in the Fraunhofer, the IPT. And the IPT is specialized in machining to turbine blades for aircrafts. And if you can see here, as you can see, normally, if you use, when you focus to machining processes, you look to an excellent surface for the stiffness of the blades, the dynamic behavior of the blades. And by this approach, via the facilitated variation, we look also to the behavior in the process when the turbine blade is in the turbine in action in the airplane. And that brings totally new aspects also for manufacturing and machining. And this, in my eyes, was a very nice result here. And this conclude my presentation. It should also only be a short comment to the research field. And in our eyes, the conclusion is We have a paradigm shift in production engineering now. If you look, there is a general approach. The demographic development worldwide needs much more products, much more resources for the people. We increase, the humankind increased and increased, and also people worldwide want to have a life like in Naples, like in Berlin, like in Paris. And for this, we need much more products. But the challenge for us as engineers and in natural sciences, produce much more by much less using of resources, much less energy, much less materials, and so on. And for this, we need a paradigm shift, and the solution can be to use the biological inspired approaches. And I'm sure that we in the future can also, by this project where we open today, or where we give the official start today, contribute to this way. Thank you so much to be here, and thank you for your attention.
Thank you, Gino.
Thank you very much, Raymond. I really enjoyed your presentation, and I think that for our university, very old university, we were 800 years old now, and very important, must have a stronger collaboration with Germany, in particular Fraunhofer. I must say that on the subject we were very much interested. In 1980, I was working mainly on composite materials structure application, and I wrote a paper on what we can learn from nature. Because really one of the main problems of our technology has been to have available many materials, but very often we didn't try to make the best of any materials. And so composite materials were the first area in which we were trying to use in and avoiding the weight and increasing the mechanical properties. You know, we saw each other with Raymond, and we cooperated in the end of the last century, because it started before 2000. I was the chairman of the Department of Materials Engineering and Technology, and Raymond was our visiting professor. Then we met once more in 2003 or 2004, and I was at that time regional minister for innovation and research, and Raymond came to visit Naples, and we really enjoyed the interaction. I am totally sure that at the moment, interaction with different countries, interaction between different scientists, interaction is one of the key words that for the future of research. It's not anymore the time that a scientist can sit in his room and just develop something that is a breakthrough in the technology, breakthrough in science. We need just to mix competence. We need very much to mix tradition, to just work with other groups around the world, just exchange, because if we exchange ideas, both of us will get other ideas. If we can exchange money, someone gives someone, one will have less money, the other will have more money. But only with ideas we really can both get an important results and grow together. I must say that in spite of this terrible pandemic that seems that we went through, and is a period which is very important for Europe, very important for research, very important for our countries, because it's the time in which we start with a very strong effort in trying to get the new generation EU. Generation EU, the PNRR, is not only a problem of money, it's a problem of mentality. We have to understand that the generation EU is not just for Italy billion of euros coming to Italy is the only different thing. We have to be able to really understand what is the meaning of this PNRR. We need to be able in 6 years to change ourselves. We have to grow up. We have to try to learn that we have to work better. We have to learn that we have to just change technology. The technology of paper and pen is finished. We have to just towards the technology of digitalization. That's the way that we have. This is a change in mentality. So that's very important. The person is very important. The way how we look, also the research. I am very strongly convinced that Italy and Germany have to be more close together because we are both countries that have been between the first and the second country in manufacturing. And we, in the past, we were just fighting for the first place. Then one electronic came in. Germany, a little bit faster than it, but still we are working very close to each other. We are two countries that have to be able to work together in order to get the best of each of them. That's what I think. And in spite, for sure, our friendship with Raymond is very strong, and appreciation of it is very high, but I feel that we have to just work in framework of large cooperation. With the Minister Mesa, we were trying to just immediately sign an agreement between Italy and Germany. It was not signed just because Germany is undergoing election in a few weeks, and but this idea stands there, and we are ready to start, not only just writing a memorandum of understanding, but put money, as Raymond was saying, in a project that see both Italian and Germans together. And Italy will sustain the Italians, Germany will sustain the Germans, but the intellectual property that we will develop and will be just joined. This is the way we have to see the future of research and of activity. I want just to say one word that is related to the young student. The young student and the young researcher, they have to learn how to move. Cannot stay in the same place for all our life. We need to go around. We need to visit different laboratories. We need to have ideas what the world around us is moving, and that's the way, the best way of growth. Federico II is a beautiful group of scientists. Is really one of the best that is among the first university in Italy, and can do a lot of things. I'm sure that with PNRR we will have also enough money to develop some very large research group, and we try to just change our situation. Already now we have a law for basic research, because I think that's an important change. We have a specific law that will give 200 million of euros just for blue sky research. Never Italy has this kind of thing. That is not coming from PNRR, but is coming from the Italian government, which is the right way how the government has to work. From their money and to support basic research. From European money, they support research from business. From research to business. That's the difference. We need to grow with new ideas, new knowledge, but also we have to learn how to use our knowledge. Something that actually in Italy is not very common. That's the reason I'm very glad to be here today. I really thanks very much Matteo Lorido, the rector, our rector, Matteo, that is doing really an incredible job in these few months in just really putting together this beautiful university. And I thank Raymond once more, who's here in Naples, just presented the opportunity for us to work together and to develop something very, really very up to date. very interesting system. Thank you so much.
Thank you. Very good. So thank you, Raymond. Thank you, Gino. I think now we can start to go into the project, so we can actually learn what this project specifically is all about. Stefan, there is your welcome.
So, first of all, I have to say thank you to all of the people who make it possible that we are starting today this project, and especially thanks to Raimund Neugebauer. Dear Raimund, you believe in the cooperation with Naples, with the university here, and you push us all together that we are able to have this project, and also thanks to you, Professor Norito, that you make it possible from the site here in Naples. I want to give today a short presentation on the project, and not on the specific topics inside of the project. What I want to mention is the overall idea, why we do this. Because when you look to the details, you find international lots of projects, but you need a common idea. This is what I want to present. But at the beginning, some words. We talk about European projects today, and when we want to be able to apply for European projects, it's not possible in the future that we say, okay, there are different groups and they connect in just for one core. I think what the expectation is that we have already established a collaboration. And to grow inside of the project with this collaboration. That's why this project is so beautiful, that we can start with the collaboration, we can see the collaboration, we can see the results of the collaboration, a specific topic. And now the question, where's the presenter? Maybe someone can. Okay, so the main headline is cognitive systems for production, and why we do this cognitive production. We often discuss about supply chains and problems in supply chains, and in the future, we have to act a bit more locally. So we're using local resources. For example, the carpenter, he decided we have a piece of wood, look to this piece of wood and make out of this beautiful table. But the table in Naples maybe looks a bit different than the table in Germany. But what we do now is we try to produce the same product at every place in the world. This is exactly what we do also with the production equipment. So we bring the production equipment that we are able to use specific basic components and made of this standardized products. And in the future, I think we want to describe the product, maybe the table, and adapt our production equipment to the raw material and have a good product at the end. And for this, we need cognitive systems to have exactly what the carpenter does to look to the raw material and make the decision what is the best product to make out of this. And so we need the transfer from the cognition from the worker who has the knowledge, and it's a bit like also Professor Neugebauer says the idea of the facilitated variation. So now what we do now is data analytics. and we start every time from beginning, collecting data, and then we say at the end, after 3 years collecting of data, what we can do with the data. In biologically, so we have the knowledge inside of the phenotypes and the variation. So when we had at the end another bird, so we start not with from beginning from single cell. So we have all the knowledge inside of the system, and this is exactly what we need. So we have the happen now. We need the knowledge, and then we go further. And for this, we have to transfer the human intelligence to artificial intelligence, and we need the cognition to have to go out from the information to knowledge and to the decision. And when we look to production systems, the transfer normally goes in that way that we just have sensors, actuators, and so on, and bring it to the production systems and say, okay, this is a cognitive system. But when we adapt other technologies like cloud computing and wireless communication and say, okay, this will be the future. And then we transfer this into production equipment. But I think when we want to have cognitive systems, the equipment itself must be changed. So we don't need very stiff systems. We don't need a system with centralized knowledge. We have to integrate, for example, embedded AI. So we have to embed the intelligence into the components of the systems, and so we need another design of the production equipment future. And this is what we want to do here in this project. So we want to apply the cognition into the system on different levels, not to have a cognitive system just with a centralized computer. We want to bring it into the structure, and so we go from two sides in the project. We start from IW with the good knowledge of production equipment, and we have here in Naples colleagues with knowledge in material science, biology, and so on. So we want to combine these things to not to have this classical approach to start with TRL 2 to 3 to 4, and that maybe in 10 years we have a new product. So we start with products from ITRL and want to put in this solution in a very fast way. And what we expecting from the future, so not just have to have a new kind of robots, we expecting a new kind of production. So and that could be that we are able to have new processes, or we on the other hand we can organize the production itself in a different way. For example, on the right hand side you see a picture from a project, also from Fraunhofer internal project, where we have the idea to have a combination of different kinds of robots working together, and the next step is that we have hybrid teams, not a team of robots, that we have a team of robots and humans. And for when we have this, we have to organize the production itself in a different way, but the production equipment must be changed. And some topics we have in mind within this project. So to develop, for example, cribbing units with the cognition inside of the cribber, not to have this with a specific device. So maybe we can integrate it in the material cognition. On the other side, we go from the classical approach from the industrial robots and to bring in a bit more flexibility in this robot, and then we can maybe easier adapt our processes to different kinds of raw materials. We can handle the uncertainties in the raw materials. This is what we want to. This the overall aspect. So we have systems or knowledge with a high TRL level, and we have some ideas with lower TRL level. And within this project, we bring the team together, working together, maybe not to have certain single projects. Of course, we start with some single projects, but the spirit here in this team is that we have maybe when we have meetings together with all, maybe we can organize things like hackathons to give them the team made of a different background a task and create within maybe 1 week a first idea, and then we can work on this in this project. So I expect that we will develop in a very fast way solutions with a high TRL level and the input from the knowledge from basic research knowledge. And this is the main headlines. What we with the starting project within during the next presentation. So I want to skip and say at the end, we heard a lot of biological inspiration, and I want to address that at the end. Of course, we can develop new production systems using the knowledge from biological, but we need at the end the researcher, we need the collaboration inside, because at the end the researcher with his knowledge, his ideas is what us brings a good future, and this is good to have it here in this team from different background, and so we are happy to hear. Thank you again. Thank you to all to give us the chance to this way.
Thank you. So now is the time of Stanislao Grazioso, who is Federico II team leader. Your presentation.
I'm Stanislao Grazioso, and it's a really pleasure for me to be here. It's a really pleasure for me to be here today, and I really thank our university and the Fraunhofer Institute to have organized this big and really exciting project. And today my talk will be about scientific and technological challenges behind BioIC. So we start from this motivation. This is a picture of our currently production systems in industry, and our motivation, which is driving all over the project, is development of more sustainable, human-centric, and cognitive production systems to tackle all the ecological challenges of the next years. And since the beginning in engineering, let's say, we always tried to replicate nature and what nature have done during the past, since the beginning. But as we can see in this slide, we have done this using materials that does not really exist in nature. In this case, we can see robots that are called anthropomorphic, but they are anthropomorphic just on their overall shape, because inside that kind of robots we can have metals, we have gears, so we have rigid materials that does not exist into the nature. So to get closer to a more sustainable production system, we have to get real inspiration from nature. And this is really motivating sentences that says that nature uses soft materials frequently and hard materials sparkingly. And so nature does not design as the engineers have designed structures so far. So probably to get closer to the ecological transformation, we need also to find different approaches into the design of production systems that could be more efficient, more productive, and more sustainable. And in the next year, there is a really exciting, there are really exciting concepts that are coming from what is called as soft robotics. So soft robotics deals with the development of biological inspired robotic systems where the compliance is embedded into the mechanical structure. So the really changing point in this case, with respect to the rigid robotics case, is that the behavior of the overall system is not the result only of the programming of this kind of rigid structure. But since the intelligence in a soft robotic system is distributed, is along all over the structure and it's embedded within the mechanical structure, we have this coupling between the mechanical structure, the controller, which is the brain of the system, and the external environment. So the really changing point is this, is that the behavior of the mechanical system is the result of the interaction of the system with the environment itself. So BioIC what addresses the biological transformation of manufacturing through the use of bioinspired soft robotics technologies. So we would like to exploit the advantages of soft robotics technology for getting closer to the biological transformation of current production systems to get to a greener, let's say, technologies for a greener world for the future. And the project is based on bioenabling technologies that we have planned to develop and we are started to develop. After we would like to apply these technologies in different scenarios, which are related to manufacturing and production engineering. And after, we would like also to exploit the results of the BioIC project beyond manufacturing. So by enabling the biological transformation also in different application areas as agri-food, as life sciences, or as domestic and service robotics environment. So those are the 5 pillars of BioEC. We started from the left-hand side from a bimanual soft articulated robot to be used for cognitive production system. And this it's inspired by the shape of the arms of human arms, where compliance is implicitly added within the joint. After, by looking at inspiration from the manipulation capabilities of the hands, we would like to embed these concepts in soft grippers. And by looking for also the movement opportunities given, for instance, by octopus tentacles, and with a variable stiffness also, we would like to develop a soft continuum robotic arm, which can be used as an evolution of the currently available soft cobots. And the growing process of plants inspires also a different design, which is called growing robot, where a material grows from the tip as the biological, its biological counterpart of the growing process of plants. And at the end, by looking for biological structures at microscales, for instance, as bacteria, we would like also to exploit this concept and these navigation capabilities that living systems have embedded in their organisms to embed into artificial machines. So this is just to give an overview of what we are calling bio-enabling soft robotics technologies, which can have a large impact in manufacturing. By combining all these technologies, we can have the realization of multiple use cases for solving real problems in industry. This is, for instance, the first one, the soft articulated robot, that in this case is inspired by the human motion of a bimanual operator that is working with an object to allow for specific deformation of the robot of the object itself. And this use case is from the forming industry, where we would like to get knowledge from an operator that does this job currently, and to embed it in a cognitive way within the mechanical robot. After, inspired by the shaping configuration of 10 octopus tentacles, we are developing soft continuum robotics concepts that can be used in the next years as robotics assistants in industry. And in this case, we have this kind of systems that are intrinsically safe, and they can go in a safe contact with the human people. And this is the really key point for enabling a really true human-robot collaboration in industrial settings. But also, we would like also to exploit after this concept, the concept of this intrinsic compliance of this mechanism to develop, for instance, applications in the service industry. For instance, as robotic assistant at home. Another system that we are currently designing and prototyping is the one inspired by the growing process of plants. This is a really growing robot that just last week we did the first experiments at our university, and it's a robot that grows from the tip. And in this case, it grows in the forward direction. And we are currently working on enabling this kind of robots also with the steering capabilities to be used for manipulation and for safe interaction with the human beings. After the technological line on soft grippers, which has a really broad set of applications. In this case, we can see a soft finger, which is actuated pneumatically and has inside embedded suckers. In this case, it's an enhanced concept of gripper that uses pneumatic air to shape the configuration of the finger and uses vacuum-based adhesion to better adhere to the surface of smooth objects. And applications behind this, beyond manufacturing, are applications related to harvesting and pick and place application of agri-food products, since also this gripper is made of silicone, which is FDA approved. And we are currently doing a patenting process for this system. Lastly, we have the technological lines on soft microrobots. So we would like to really exploit the biological principle of building blocks of living organisms to develop, let's say, bottom-up manufacturing strategies, biomanufacturing strategies, which allow to develop monodimensional, bidimensional, and three-dimensional structures organized as, let's say, micro-robotic arms, starting from let's say, the cell as in the biology. And this is a really challenging task, which deals with not only fabrication of the microparticles, which are, let's say, the cell of the future robot, but also on local control and the local actuation of these microparticles to allow for desired movements and desired capabilities. These are the scenarios that we are looking for. So we started from autonomous cognitive production with the soft articulated robot. And in this case, we are looking for embedding within the mechanical structure the cognitive capabilities of a human. And in this case, it's a just closed cell where we would like to make the robot doing the task in as accurate as possible, as human experts currently do. The second lines of research is collaboration. So soft robotic structures have this really key concept and key important feature, which is safety. And which is safety with the human beings. So we take inspiration from the movements of, for instance, octopus tentacles or growing plants to allow for development of intrinsically safe structure that can work close to humans at the beginning in the factory of the future, but also in the house of the future. We can have these kind of systems to help elderly people in a safe way. And lastly, the research line of biomanufacturing. So we would like to start a really new concept of how we how we manufacture a system, starting from what is for the robotics, the living cell that is for living organism, and to assemble it and to control it in a way that is much more biologically inspired. So we started for manufacturing, but as the Industry 4.0 experience has given us the technologies that we are currently developing for industry, will have a broader impact also in other domains, starting from agri-food production to healthcare and to service robotics. The preliminary results that we have achieved so far, we started in November with this project, and for now we have defined the preliminary design of the technologies, and we have started, as you may have seen from the videos, the realization of the first prototypes. We have also, let's say, frozen the first example of the demonstration use cases and the equipment of a new laboratory that is in progress for the project. We currently have the first 3 scientific publications related to the Bioic project and 1 patent application that we are currently doing related to the soft gripper. So this is the team at Unina side. There is Professor Lanzotti, which is the project leader. I'm honored to be the team leader for the technical and scientific activities, and I'm working with Mario Selvaggio and Raffaele Vecchione daily for doing this kind of really exciting project for us. And there is a steering committee composed by Professor Bruno Siciliano, Professor Paolo Netti, Professor Leopoldo Angrisani, and Professor Giuseppe Di Geronimo. On the IW side, we have Professor Stephanie Hillenfeld, which is the project leader and the head of the part of the Fraunhofer IW. There are Arvid and Linda, which are the team leaders of IW. There is Christian, there is Willem, there is Malte, working currently on the project. And the steering committee from the Fraunhofer side is composed by Dr. Kurz and Professor Drossel. So I really thank you, and we are looking for biological inspiration and technological development as a driver for a sustainable value creation.
Okay, thank you. Now is the time of Antonio. So Antonio Lanzotti.
Dear Rector Lorito, dear President Neubauer, dear Director Bianco, and dear Minister, ladies and gentlemen, I'm really proud to be here this morning. And the launch of the project is not just a ceremony, but give us the opportunity to thank people who cooperated to this end. And as it has been mentioned that starting from Professor Francesco Caputo and starting from Professor Luigi Nicolais, that at the end of the last century started the cooperation. I want to mention Professor Massimo D'Apuzzo as President of the Polo of Science and Technology, also a colleague, Professor Roberto Tetti, that I met more times in Chemnitz and Dresden than Naples, even if we belong to very close departments. I have to say just that we work 1 year, more than 1 year, to write the project, to develop this project. And we used the emergency time. We started the project before the emergency. We had a meeting in Rome, in Dresden, and then in Rome and in Munich at the beginning of 2020. I had my last mission before a pandemic emergency. And then we work in smart working. We had meetings, but we work with the hope that the emergency can be overcome, and we want to work for a sustainable future for a very challenging project. And now these efforts have been compensated by results, by the project that is moving on. And I have to, as Stanislao in the previous presentation mentioned the colleague that belonged to the steering committee, I want to mention the department because the first time I believe in very well connected the way 3 departments and 1 center of Ateneo cooperate this project, the Department of Industrial Engineering and the Department of Electrical Engineering and Information Technology, and the Department of Chemicals, Materials and Production Engineering. So I thank Professor Nicola Bianco this year, help for the support, Professor Luigi Carrino for the PAPI, and Professor Giorgio Ventre, that is the director of Department of Information Technology. And also there are labs in this department that have worked till now on these topics. But the aim is to build a new lab, a joint lab among us and a joint lab in cooperation with IW. And last but not least is the important cooperation with the Center of Advanced Metrology, directed by a member of the steering committee level, Langrisani, that is an active part of it. I have to say that there is a new ecosystem, Naples, the area of San Giovanni, where the new lab will find home. I have to thank Professor Eduardo Cosenza that for his effort to find home and to work to this end. And in the area of the innovation hub of San Giovanni, we had a mind village and a palace of creativity and innovation. And the Bioic project will work very close to this new project and these new labs. And in that area, we now have 3,000 students, and in the future we will have 7,000 students that we studied there and that we can get experience in our labs. And I have to say also that Federico II is the leader of a competence center, one of the 8 competence centers approved by the Minister of Development in Italy. And there is a large hub, Meditech, the Meditech Center. Belong to this hub 5 universities of the Campania region, 3 universities of the Puglia region, and 22 cutting-edge industrial partners. And this consortium is devoted to promote and transfer the research results to the region, but they work for the Italy and they work for the EU communities and abroad. So there is a very good opportunities. Also in the Ateneo, we have a network that is called the Task Force of Ateneo, Industry 4.0 and Sustainable Development. Both are directed till now by our colleague, Professor Piero Salatino. And it is a network of 800 researchers that belong 21 departments out of 26, from biology to medicine. So the challenge that we face, that we have to face with our project can be faced together with our colleagues. So a very, very important ecosystem that can, the Bioic project can grow. Which is the vision that we have? As many speakers before me, we want to consolidate the excellent scientific result that we get till now. We want to build a strong team. I received the text from German, from our colleague, from Professor Negebauer, for the Italian. Finally, Italy won the European Championship as a European country. And we want to win together. We want to win together inside Federico II. We want to win together Fraunhofer, together develop together our colleagues in Dresden. Because we believe that in this case, with giving value to the complementarities of competencies and to the synergies and working in synergies, we can get a better result than if we work alone. And I believe that Fraunhofer is one of the leading player in the world in the valorization of product of research, valorization of patents. So we believe that in this 5-year-long project, we can develop a common strategy for marketing and for transfer the result of the research to the society. And this is a really important result. And as also the chance to develop common spin-off should be also supported by the Campania region, a good way to valorize the result of this project. I want to say that this is the first pilot project of the Italo-German cooperation that was mentioned before, that was signed in an agreement between our Minister of Research, the former Minister, Professor Gaetano Manfredi, and the President of Fraunhofer Gesellschaft, Professor Negebauer. We believe that when this agreement will be supported also by the new government, the minister, we can start and we can work together with other Italian universities to strengthen the relation with the German partners. Also, Campania region is nurturing this innovative ecosystem and will strengthen the international relationship between Saxony and German. And finally, I have to say that President Negebauer was appointed by PhD, honorary PhD by our university. So I believe that as a Federician, he's working very well for his university. And I thank all of you for involvement and attention. Thank you very much.
Thank you, Antonio. So now is the time of Valeria Fascione, Regional Minister for Research, Innovation and Startups. La Faccina, lo c'è?
Okay. Sorry. Okay. Good morning to everybody. I'm very happy to be with you today. Thanks to Rector Lorito and Professor Nicolais for your kind invitation, and let me say my warmest welcome to our friends from Fraunhofer Research Center. We are very pleased and honored to work with you, and a special thanks for the professor and the team from Italian side and German side that developed such a challenging also, as what was said, in a very difficult period, so double job, and I really hope a great success for this with so high potential of research project. Just some comments on the project. I liked very much the fact that it involved different departments, many disciplines from both sides. It's the right way to face the new challenges in research and innovation, to mix competencies and to have mixed together the bio approach with the more technological approach, design, inspiration, sustainability, and also the fact that you will have industrial application in many sectors. I was really impressed by the octopus robots and by the microrobots, new frontiers, and this combination of biomaterial and the application, I think, is very new, very long-term visions, and I'm sure you can have a lot of very marketable application with the objective to work on new processes, you said new products, but also and future technologies. Definitely, I think that future technology. So all this mix of potentialities, strong value to. I wish you all success for the results. Coming from the opportunities to strengthen cooperation activities between Campania region and Germany, I must say that we also have already in the past developed some cooperation in the field of the exchange of startups, especially startups, because you know that Germany and Berlin, for example, is one of the most important living lab for startups. And so we had in past years a different opportunity to visit some creators and to participate in this in different research and innovation cooperation programs. But now we have to up the future, and we are in the phase in which the new programming, the new European programming is quite ready to have to be put in action. 2021, 2027, and I can assure you that from our side, all the possibility to reinforce the international cooperation in startups, tech transfer, valorization of human capital, talents are all already decided and included in our new programs, in our regional research strategy. So we will have a new to internationalize the human capitals, new funds to sustain students, for researchers, new funds for setting up new joint labs. And I like very much the fact that you have not only setting up an important research project, but also a joint labs. It's important to have some physical labs where you can work together and when you can build many projects on these shared infrastructures. And so my message is that we are very open to identify and also more structured opportunities. We can finance the parts of the project and co-finance possible startups or new outcomes that you can develop. So we strongly believe in opportunities between Germany and Italy, because we have the same key strategic, also industrial sector in common. Just to think for aerospace, but also life science, new energy, alternative, for efficiency energy. So we have a lot of common interests. Imagine opportunities and then make them big. Thank you very much.
Okay, thank you very much, Valeria. So we are at the end of this morning. Just a very, very short conclusive remarks. First of all, I would like to thank also Professor Franco Caputo. I have seen you before, so I understand that you've been also an inspiration for this project. Only two things. I think we all are convinced now that this project, as it holds, has everything we need, needs to be a successful project. We have seen surprising new ideas. The idea of the octopus, Valeria, is very intriguing, especially for us. You know, we like very much octopus from all the point of view. There is a project where we have excellence in research, but I would say excellence in curiosity-driven research. That's another important issue. Potential application in technology development and transfer given to area where a big university like Federico II can actually learn on it. So when you have new technology coming out, the university should also follow these things, this track, and also produce innovation in terms of education. So this project, they will probably create in the future new jobs or new kind of jobs, which we can learn to prepare the people for just following the activity of research. And also, I would say the passion of the people participating, we have seen in the presentation. So everything is there, and also this will be a very successful project. That's the reason why Federico II is investing specifically in this project. And finally, I also like to thank the 3 departments present. I see one of the director here. And I also must to tell them that this project, I will get to you, this project will also be extended to other departments. So, because that has to be an opportunity for the university, for this big university to collaborate and to make project, including also the CESMA, to a project that make departments, disciplines, and research together, Antonio, together. So I count on you also from this point of view. So thank you very much to all and welcome to our guests, and we'll see you when we will present the results of this project. Thank you.